The second question is about the moment conditions approach. So here, this is the most general vector case with x1 is exogenous regressors and x2 is endogenous regressors. So we have exogenate assumption for x1 and exogenate assumption for the instrument that is excluded from the equation. Okay, and then we have to find moment conditions and we have to find the uniqueness of the solution. Pretty straightforward. And by the way, I'm using the same notation as in the lecture note. So let me write down. So simply speaking, we have three assumptions anyhow. Linearity, yi equals x1i transpose beta 1 0 plus x2i plus beta 2 0 plus ui. Linearity, exogeneity on x1 and z2. Okay, together we can write them as ziui. Okay, the dimension, by the way, here dimensions are different, like 0 vector. And finally, full rank assumption means rank of expectation xz transpose is k, where k is actually the number of unknown parameters, right? We are looking to identify k number of parameters, so the rank should be k. Then given these assumptions, the moment conditions are from this, pretty obvious, right? And the reason why we cannot use this as a moment condition directly is because u is unobserved, right? So what we have to do is just rewrite the moment condition into observed. It looks like alpha. Sorry. So observed parameter like this. Okay, I replaced u with this term. Then, as you know, it is only about observed data, right? Z is observed, y is observed, x is observed, and the other part is unknown. That is the argument of this function. So we are going to define gi beta as z times yi minus xi transpose beta. Right? Okay? So other than beta, everything is observed. So I denote that as gi. Then, you know, gi beta 0 is 0. Right? Because as you know, this is our assumption and these are the same statement. Right? This and this are the same statement. So then the next question is beta 0 the unique solution or not? That is the identification problem. If it is unique, we can identify beta 0, but if there are more than one solutions to these moment conditions, that means there could be like observationally equivalent parameter values. So then identification fails. That's why we are looking to the uniqueness. Okay. Now back to the moment condition. Oh, sorry. So this equality is actually linear equality. As you see, it is ziyi minus expectation zixi transpose beta equals to 0, right? So then it looks like, say, let me write it as B. Let me write this as A. B is m dimensional vector and A is m by k dimensional matrix. So it looks like A times beta equals B. We if A was invariable, then we could simply write it this way. So in the classical linear regression, I said this is the closed form solution if possible, but we do not know if m equals k or not. If m equals k, then we get this but it's not general enough in here. So we have to argue that there is only one solution, okay? We know that, let me prove that. So this is the equation we have, linear equations. We know beta 0 satisfies this, okay? Beta 0 satisfies is one of the solutions for this system of equations. And now we are like, suppose that there exists beta tilde that is different from beta 0 that also satisfies this equation. If there exists such a beta tilde different from beta 0 but satisfying the moment equation, then beta tilde is another solution. So beta 0 is not uniquely identified. I'm showing that this is contradiction. It cannot happen, right? Because if so, if that is the truth, then you can easily find that this equals to 0. But look at the lemma. Lemma says if A is n by k matrix and if rank of A is k, then A times a vector equals to 0 is satisfied only when the vector is 0. Okay? So this means if you have these linear equations, the solution V is only 0. 0 is the only solution because all the columns in A are linearly independent. So that means if there was another beta tilde, then it should satisfy this one by lemma. It means beta 0 minus beta tilde should be 0. But that means that is contradiction to this. They cannot hold at the same time. So there is no such beta tilde. So this is the proof for identification, the uniqueness of the solution.